Hi, a friend of mine asked if I could have a look at this gadget, and what this is, it's a generator control panel manufactured by a company called Deep Sea. And there's all the connections on the back for the generator. Now this isn't actually faulty, but he does have a problem with it. So what I'll do, I'll just couple it up to a bench power supply. We'll power it up and I'll show you what's going on. And resume. Right, I've got the bench power supply hooked up, so we'll switch it on. And we'll probably get loads of alarms going off, like so. Because we haven't got sensors and things hooked up to it. But what he wants to do, he wants to adjust the shutdown time and the startup time on the generator. Now to do that, I've looked at the manual, and you hold down this button and that one, and it says enter pin number. Now the company says that they don't actually set pin numbers on these, and it's up to the owner or the fleet hirer or whatever to set their own pin number. And if you lose it, there's no back door, there's no way to reset it, and you've got to return the unit to the company for them to reset it, which seems a little bit inconvenient, I thought. So he said, could I have a look at it and see if I could figure out how to reset the number? I mean, you can enter sort of like, you know, we'll try 1, 2, 3, 4 for instance. And then it doesn't actually let you into the settings menu. So what I'm planning on doing is taking it apart, see if we can find some kind of memory chip in there, and then hopefully we'll see if we can read it with the laptop and see if we can figure out where the pin code or whatever's stored. Right, let's get into it. Right, just switch the bench power supply off there. Just unplug this. That actually comes apart quite easily, there's no screws in it. I just need to press this little tab here. And then the top comes off. Just put that out of the way somewhere. Right, so we have two boards. We have a display board at the front here, which is just an LCD with a sounder and a couple of chips there. And some buttons. Let's see if we can unplug that. And this is the main board. Let's zoom down a bit. Now I may need to bring the microscope in on this so we can have a bit of a closer look. Yeah, I think I'll bring the microscope in. We'll get a bit closer look, see if we can see any numbers on these chips. So this is the main IC here. And if we look down here, it looks like we've got a serial EEPROM. I'll just see if I can get the number off it. Might have to angle it slightly. Yeah, it looks like a 24LC08BI. Let's see who that was. So hopefully that's where it's storing its settings. So I think what we'll do, we'll get the Rework station out, we'll take that off, and we'll try and get it in the EEPROM reader. I'll just refocus this microscope slightly. Alright, I'll get the Rework station out. I think I'll just add a little bit flux first. Alright, we'll fire up the Rework station. Right, there we go. Right, I'm just going to clean the area off with a bit solder wick. I'm just going to use a bit IP and a cotton bud now. Right, put some fresh flux on there. Now I'm just going to put some leaded solder on these pads ready for when we refit the chip. Right, I think that should do. Right, let's see if we can get this chip in the EEPROM programmer now, and we'll see if we can fathom out if the pin code is actually stored in this chip. Right, I've got the chip in the programmer here. And I've had a few people asking about this programmer. It's the XG-ECU T48, in case anybody's interested. Right, so I'll just select the correct chip, which is this one here. I've already got it selected. And then we'll hit read and we'll see what we get. Right, it seems to have read something. And I can see some text in there already. P539 event log file. Copyright 1998 Deep Sea Electronics PLC, all rights reserved. Let's have a scroll through this, see if we see anything. I mean, to me that looks like some kind of table for some kind of log file there, I would say. And then it looks like we've got a separate block of data after that. Now I think this chip holds the running hours of the generator as well. But I can't see anything that immediately looks like a pin code or anything. I can't see any ASCII characters or anything like that. Not that it might be stored in ASCII, it might just be stored as normal, just binary. I mean, we've got here 0107, so it could be, well, something like that. Well, at least we've read the data now. So I think I'll save this file, we'll pop the chip back in, and we might try some of these values to see if any of them work. Like we've got like 1200 there, or 0030 possibly, or 0105. I mean, if it doesn't work after we do that, what we could do is possibly blank the EEPROM, try it in, and then see if that restores everything to factory defaults. But it mightn't actually be stored in this chip. It might actually be stored in the flash memory of the microcontroller, and this might just be for purely for log files. I don't know, but I think we'll find out. Right, I'm going to save the binary file and then we'll pop this chip back in. Right then, let's get this chip popped back in. I think that should do. Right then, I'll just let that cool down and then we'll try some pin codes.
A few moments later.
So, I've been trying different pins, well, what I think could be pins that are in this flash dump, and I haven't really gotten very far. So what I'm thinking is, I might take the EEPROM out, blank it, fit it, see if the pin code still exists. If it doesn't, then what I can do is on the blank EEPROM I can set a pin code and try and see where that pin code's stored. And then we might be able to find out what the original pin code was. So I think I'm going to do that. So I've got the chip in the programmer again. So I'm just going to check that it's making connection properly. I'll just try reading it again. Yeah. Right, well now we'll try erasing it. Not empty. Ah, that must check that as blank. Where's erase then? Does this have an erase? Yeah, there's an erase button there, but unless you've just got to clear the buffer and then just program it. Continue to blank programming, yes. Right, let's see if it's blank now then. And it is. Right, let's fit it and see what happens when we power it up then. So I've just finished installing the chip again. Let's connect the front panel back up, which is a little bit fiddly. So don't give you a very long connector. Right, let's get that there. Let's switch this on and see what it does now then, with the blank chip. Right, once it's silenced, So I should be able to press that and that. Hey! Configuration. Right. We didn't have that before. Yeah, that's what he wanted to be able to do, change all the configuration like that. So it looks like just blanking the EEPROM and then fitting it gets rid of the pin code. Now what I'm thinking, I wonder if we could find out what the original pin code is. If I set a pin code on this of, let's say, 1234, and then we read the EEPROM again, we could try and work out where that pin code is stored. So I think I'll do that, see if we can figure out where the pin code's stored, and then we can find out where the original pin code was, just in case anybody else wants to find out what the pin code is on one of these. Right, I shall find out in the manual how you program a pin code, because I've not done this before. So it seems to program a pin code you need some special Windows software that was written for Windows XP 98 and 2000, and some drivers, and a special interface called DSE 810, which unfortunately I don't have. So we're going to have to find a different way of doing this. So I've removed the chip again. So this is the chip after we blanked it and placed it in here and switched it on and initialized the chip. So we'll read this chip again and we'll compare it to the data that we had in the chip beforehand. So let's go back to the computer screen and I'll just read this chip. Right, so it's read it. We'll just save this file. So I'll save it and we'll call it no PW for no password. We'll just save that. So I'm going to use a program called Ultra Edit, and I should be able to compare both of these files. Right. So it looks like there's a few differences at the start of the file there. I mean, that could be some kind of checksum or something possibly. Although it even seems unusual being at the start of the file, because checksums are normally at the end of a block. This is the logs, which are now blank. That's all these differences here. And I think this part here, starting at 350, is the configuration data. And there's quite a few differences there. I've noticed here we've got 3412, or if you read it the other way, it's 1234. But I've tried that and that's definitely not the password. And it's in both files. So we haven't set a password on this one. So whatever the password is, it's the differences between these two files. So what I decided to do was have a look at the data in the EEPROM and start blanking out certain parts of it. So what I did was, just scroll down here. The top part of this just looked like log file info. In this section here, it looked like configuration data. So I went like this. I started blanking off this section. So I thought, right, okay, we'll blank off this first part until there. And I wrote that back to the EEPROM, refitted the chip, tried it again. And then I blanked out this section up to here. Wrote that back, tried the pin, it was still set. And then I thought, right, okay, we'll erase it until this section. And the pin was still there. So then I thought, well, we've only got this little bit at the end. So I erased that bit and the pin went. So then I knew that the pin had to be in this last line of the code in the EEPROM. After I blanked that line, I read it back again. And I noticed those just a few bytes had changed. These 3412, or if you read it the other way, it's actually 1234, so I think it's in reverse order. So what I did next was to blank these 3 bytes, and then I tried these bytes. And what happened here was the pin disappeared. So I knew it was in this last line here, so we'll read that back in. So we've got D007 or 07D0 if you read it the other way. So we get a calculator up and we'll do 07D0, we'll get the value of 2000. So let's try 2000 as the pin code and we'll see what happens. So I'm just going to power this on. I'll just switch the bench power supply on. Just silence the alarm there. We'll press. Just do that again. Right. So now it wants the pin number, so we'll try 2000. So we'll go 2 0 0 0 and we're in configuration. So that's where the pin code's stored. Now what I'm going to do, because the guy doesn't want a pin code on this, even though we actually know the pin code now, I'm just going to erase those bytes, leave the rest of the configuration as is, because obviously I'm not sure how this is supposed to be configured, and if we blank the whole EEPROM, we'll lose the whole configuration. So what I'll do next, I'm just going to blank those few bytes, write it back to the chip, refit the chip again, and then I think we'll wrap up the video. So I've had this chip on and off quite a few times now, so I'm quite used to doing it. It would have been better if I had one of those SOIC test clips, but then again I'd have to have the processor and reset and power the chip separate from the rest of the logic or whatever. So it's not too bad to do this, it only takes a couple of minutes once I get the chip hot enough. And there we go. So I thought I was finished with this, but I started having a mess around with the buttons on it, and I came across this part here. And what it does, it lets you cycle through all of the different stats of the control unit, and I noticed it shows the engine runtime hour and the number of starts. And if we go a little bit further on there, it also shows how many kilowatt hours that the generator has produced, the kilovolt amp hours, and the kilovolt reactive amp hours as well. So I thought, well, I know these values now, I wonder if they're contained in the EEPROM as well. So we'll just pop back to the computer screen and we'll have a look. So what I've done, I've shown the data as 16-bit because some of these values are 16-bit and some are 32-bit. So the first one I've highlighted in green here is actually the number of starts, which is in the EEPROM 0B3A, which if we convert that to decimal is 2,874, which is equal to the number of starts. So that's what that one must be. The next number that I came across was this one, which is 00500171, and that equals 328,049 or 32,804.9 kilovolt amp hours. The next number that I discovered was this one here, which is 00011801, and that equals, if we convert that to decimal, it equals 73,217, which is the 7,321.7 kilovolt amp reactive hours. The next one I came across was this one here, which is 0004C538, and that one is the kilowatt hours and equals 31,263.2. But I still couldn't find the engine run hours, and that took a little bit more working out. And it's actually this number here, which is 0147 E2FF. And what that equals is 21,488,383. And it turns out that that's actually the number of seconds that the generators ran. So if we divide that by 60, we get 358,139.7 minutes. And then if we divide that by 60, we get 5,968.9 hours. So that's how the hours are stored. And the pin code is this value that I've highlighted in yellow here, 07D0, which is 2000. Well, that's what it was before we changed it to all zeros, and basically that disables it. So yeah, so that's how the pin code's stored as well. So with this newfound knowledge, I wonder what happens if we change some of these values. I wonder if there's any kind of checksum or any kind of checks in there just to stop you from arbitrarily changing these values to anything that you want. So I think I might try that. So I think I want to pull the chip off again. We'll put it in the programmer. We'll change some of the values and we'll see what it displays on the display. So I've just removed the chip again and put it in the programmer. So we'll go over to the computer screen and we'll just read the chip. Right, that's the chip read. So I think what we'll do is we'll try changing the number of starts to 101. So that's this value here. So 101 in hex is 0065. So that's that one done. And I think we'll change the hours to 1003. So 1003 hours is in hex is 0037 and 18B0. Right, so we'll write that back to the EEPROM now. I'll just program it. Right, that's it programmed. So we'll now fit it back to the unit and we'll see what it displays now. Or if it'll come up with an error. We'll obviously put this back the way it was before giving it back. Right, let's get the control panel and put this back on. And let's power it up. I'll put the bench power supply on. And just silence these couple of alarms. There we go. 1003 hours now. And 101 starts, so that worked exactly as I expected. And we can get into the configuration as well. Right, so I'll put that back the way it was, but well, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.